Hi friends, today we're going to spend a little bit more time working on multiplying and adding square roots. This is a concept that can be challenging because it combines a lot of different things that you have learned in the past. So let's talk about a couple of those concepts that are going to be really important to remember. The first one is what happens when we add square roots. Remember that if I add something like x square root of 3 and 2x square root of 3, the first thing I want to check for is to make sure that they have identical square roots. And if they are the same, then we move on to checking what's out front of the square roots or the coefficient on that square root. And I want to look at the coefficient on the square root, 2x and x, and I want to make sure that they are like terms. And if both of those things are true, then we can combine them. So remember, we have a sneaky 1 on the front of that x. So this is 1x square root of 3 plus 2x square root of 3, which would give us 3x square root of 3. That's the first concept we need to remember. The second one is multiplying square roots. So remember that if I have, let's say, 4x square root of 2, and I'm going to multiply that by 3 square root of 5x. So we're just doing a multiplication problem, and remember that in multiplication, we can rearrange the order of the things we're multiplying. This only happens in multiplication and addition, but for multiplication, I can regroup this in a way that makes more sense to me. So I'm going to group up these coefficients on the front, the 4x and the 3, and I'm going to multiply them together to get 12x. And then second, I'm going to group up the square roots. So square root of 2 and square root of 5x. I'll multiply them together to get square root of 10x. Now, I want to check that 10x and see if I've maybe made a perfect square in there when I did that multiplication. I could have. 10x can't be simplified, but it's something we always want to check. All right, so let's look at some examples of these. Let me throw those up on the board real quick. All right, let's look at some examples. So this first one I have written up, I have 2 square root of 3x times parentheses 2 square root of 2 minus 5 square root of 3x, close parentheses. So let's just take this very carefully, and we want to notice that the first thing we're going to do is distribute this 2 square root of 3x to both terms inside the parentheses. Don't let the fact that there's square roots bother you. We're going to treat it just like any distribution. So let's write out that multiplication. I have 2 square root of 3x times 2 square root of 2 minus, because remember we keep that sign from the inside of the parentheses, 2 square root of 3x times 5 square root of 3x. All right. Now, in each group, we want to combine the outside piece, the coefficient piece, and combine the square root piece separately. So on this first one, I have 2 and 2, which are my coefficients. I'll multiply those together to make 4. And then I have a square root of 3x and a square root of 2, which I'll combine together to make a square root of 6x. Let's move to the second chunk of things we're multiplying together. I'm again going to look at the outside numbers, those coefficients. I have a 2 and a 5. So I'll write down minus 10, keeping that negative from the line above. And then looking at the square roots, I have a square root of 3x times a square root of 3x, which I will combine together to make square root of 9x squared. Now, you might have seen that and said, well, gosh, 9x squared, I know what that is, because I took a square root of 3x and I multiplied it by a square root of 3x. And if you notice that, good for you. Good observation. So when we look at 9x squared, this is one of those situations where we need to evaluate, have I created a perfect square that needs to be simplified? And in this case, yes. So in place of 9x squared, I'm going to write 3x. All right, I'm going to rewrite on the next line 4 square root of 6x minus 10 times 3x. Checking that square root of 6x, there's nothing inside it I can simplify, so it stays just as it is. So my final answer would be 4 square root of 6x minus 30x. All right, so lots of steps there, but as long as we take it just one at a time, it's not so bad. All right, the next one, I've got two binomials multiplied together. I have square root of x minus 4 multiplied by square root of x minus 2. We have two binomials, so we're going to FOIL to simplify those. So FOIL, first thing we're going to do is multiply those first terms together. So square root of x times square root of x, I'm just going to write down. If you already noticed that that is going to be equal to x, awesome. And I'm going to do that in the next step. All right, outside. So outside terms, I would have square root of x times square root of 2, and we will keep that minus from the negative square root of 2 here. Inside terms, that would be minus 4 times square root of x. We can't combine those together because the 4 is not inside a square root. So we would just write down minus 4 square root of x. And then finally, the last terms, minus 4 times negative square root of 2. Minus times minus gives me positive 4 times square root of 2. All right, so let's go back and see what we can simplify. Where I have square root of x times square root of x, that would be square root of x squared, which is also equal to x. I'm going to write down that x here, but I'll make a note over here that the square root of x squared, remember that is just equal to x. All right, then I have a minus square root of x times square root of 2. Remember that those get combined together because they are square roots being multiplied. So I have a minus square root of 2x minus 4 square root of x. There is nothing we can do to simplify that. And then plus 4 square root of 2. Now let's look at these last two terms here. We want to see, are they like terms? So the first thing I check is the square root. Do they have identical square roots? No, then they can't be combined. All right, so my final answer on this one would be x minus square root of 2x minus 4 square root of x plus 4 square root of 2. All right, let's look up here. I got a little fancy here. I didn't write out the two binomials. I just wrote out that it was a binomial squared. But remember, we know that this is really, oh, let me say what the problem is first. This is in parentheses, square root of x plus square root of 3 squared. So we know that this is actually square root of x plus square root of 3 in parentheses times square root of x plus square root of 3. And it's often helpful to go ahead and write that out so that you can track where you're going. And you can also draw your lines to FOIL it. All right, so FOIL, first terms, square root of x times square root of x. As we saw before, this is going to give us square root of x squared, which is just x. All right, outside, square root of x times square root of 3. This is going to give me the square root of 3x. Inside terms, I have a square root of 3 times the square root of x, which will give me, again, square root of 3x. And then last terms, square root of 3 times square root of 3, which would be square root of 9. And I'm going to go ahead and write it down as square root of 9. We'll simplify that on the next step. Okay, I want to show you something really important. Remember that we have a sneaky coefficient of 1 on the front of both of those square root of 3x's. This is where some students get confused, is combining these two together. So remember, the first thing we want to notice is their square root part exactly the same? And it is. It has a 3 and an x in there, and that can feel complicated, but it is exactly the same. All right, next thing we check, are their coefficients like terms? 1 and 1 are in fact like terms. They're the same, so we can definitely add them. So when I add 1 square root of 3x plus 1 square root of 3x, I'm going to have 2 square root of 3x's. This is similar to if you were to add 1y plus 1y, you'd have 2y's. Okay? All right. Now that x on the front just stays the same. So I'm going to write down x plus 2 square root of 3x. And then finally, in place of square root of 9, I'm just going to put a 3. And that would be our final answer. X plus 2 square root of 3x plus 3. All right, let's look at another one like that. I've added a few more numbers in there to make it slightly more complicated because I want you to see one of the most complicated ones you'll encounter. All right, again, I have a binomial squared. So in parentheses, 2 square root of x minus 3 square root of 2, whole thing squared. So the first thing I want to do is write down this problem, writing out both of those binomials, mainly so that I can draw my arrows when I FOIL it and keep myself on track. So I'm going to write down parentheses 2 square root of x minus 3 square root of 2 times parentheses 2 square root of x minus 3 square root of 2. All right, I'm going back to all the colors so that we can see where everything came from. First terms multiplied together, I have 2 square root of x times 2 square root of x. And I'm going to go ahead and write it down that way so that we can see where everything came from. All right, outside. So outside, I have 2 square root of x times 3 square root of 2. And that's going to be subtracted because of the negative sign on the 3 square root of 2. All right, inside terms, I have a minus 3 square root of 2 times 2 square root of x. And then finally, my last terms, minus 3 square root of 2 times minus 3 square root of 2. And you'll notice I changed that to a positive because I have a negative times a negative, which makes a positive. All right, so I've written this all out and I have kind of a mess, but that's okay. We're going to go back and simplify it. So we'll start at the beginning. 2 square root of x times 2 square root of x. So the 2 and the 2 get combined together in multiplication because remember we can change the order of our multiplication. Square root of x times square root of x is just going to give me x. And I'm going to write that down over here as well, just so we remember that rule. This is going to be very important as you are simplifying square roots. All right, so my first term is done. I just have a 4x. All right, let's move to this next one. I'm going to keep the minus. Multiplying the outsides together, 2 times 3 gives me 6. Multiplying the square roots together, I have square root of x times square root of 2 is 2x. All right, that one's done. Moving over to the next one, I'm going to keep the negative here. Multiplying the outsides together, 3 times 2 gives me 6. Square root of 2 times square root of x gives me square root of 2x. Hey, those look familiar. And then finally, on the end, I have 3 times 3 gives me 9. Square root of 2 times square root of 2, that's just going to be 2. So you could think of it as square root of 4, or just write down that 2. And remember, it's going to be multiplied by that 9, because all of this on the end, the 3 square root of 2 and the 3 square root of 2, are all multiplied together. So I'm leaving that as 9 times 2 right now. We'll simplify it in the next step. All right. Now, these two, the negative 6 square root of 2x and the other negative 6 square root of 2x, we want to figure out what to do with those. First thing I'm going to check is, are the square root parts exactly the same? Square root of 2x, square root of 2x, they are. Now let's check their coefficients. Are those exactly the same? 6 and 6. Actually, not exactly the same. Are they like terms? So 6 and 6 are like terms. We can combine them. First thing I'll do is go ahead and write down that 4x from the previous line because nothing about it changes. Now we're going to combine these. So minus 6 square root of 2x minus another 6 square root of 2x. Remember, this is like I owe you $6 and I borrowed another 6. What do I owe you? Well, $12, of course. So we would have a minus 12 square root of 2x. And then on the end, 9 times 2, I'll rewrite that as 18. So we have 4x minus 12 square root of 2x plus 18. No like terms remain, so this is our final answer for this problem. These can be challenging. If you are having a hard time with these, I would suggest asking an AI source for some similar problems to the ones that I have up on the board and asking it to give you both the problem and the answer so that you can work it and then check yourself. If you have a hard time with that, you can then ask it for a step-by-step solution to help you get comfortable with this concept.